Hello, my name is Oljas and my partner's name is Bajan Nurlanlo. In this video, I'm going to tell you about our project's proposal. Let's start. So our project is intended to denoise the noisy audio files. So let's take a look at these audio files. So here we have Luperman.off. So as you can see, and here, this is the original version, but we are adding some into it, so you can hear it now. So our model's task is to denoise it and make it cleaner. So let's look at the result. So it's not that clean, but I think that it's better than nothing. So let's get basic-tools.py. This was created by us. So here you can see many functions which are intended to read, write the audio files, also normalize them. So also here is the function in order to compute the metric SNR, which is signal to noise ratio. Here is the function to make a range dataset. To reconstruct full is to use the prediction. The next one. This is cut file. Here we are loading the audio file and normalizing it. It's taking the first 30 seconds because taking longer will be time consuming and less efficient. So here we are saving it. Next, let's go to the add noise part. So here we are collecting necessary libraries and normalized data, which is our audio file. Next, we are adding noise. Here, the noise varies from 0.1 to 0.5 noise level. So we are adding at the level of 0.2, reading the normal random variables, which is 0.2. So here's the visualization part. It was a Pixel library. We constructed these graphs. So as you can see, this is the initial clean signal, Luperman.wav, which is like that. And this is the noise signal, which becomes thicker. Here's the noise, as you can see. So let's be saving these files. So let's get into the model part. So we are importing necessary libraries like Rich, K-neighbor regressor, SVR, random forest regressor, and also standard scale, and so on. So here we are loading data, and then we are preparing the data. So here is the radius is equals 21. What's radius? It is the number of elements which we are going to take from the right and from the left side in order to predict the initial point of the signal. So here is split 80%. We are making the range dataset, and we are taking X train and Y train as initial entry points. So here is the difference from other tasks is that as audio file is time series, we are taking initial 80% of the audio file, and the rest 20% of the audio file will be testing part. So we are not generating splitting them randomly. So next, these are the list of the models we are going to use. We name them candidates. So here is the we are adding command signs because it is really time consuming to process each model. And for example, after running the reach, we have spent 2 hours in order to take the results of the other model. So we decided to leave only this one. But if you delete these uh, symbols, you can get the result totally. So next one, best is our variable, which is the model we are looking for, which suits best for our task. So here we start constructing our table. And these lines of the code is used in order to find the best model, which gives best metrics. So here we are training the model. So this is the noise, which is after, which is the result of our model after training. So here, signal to noise ratio, and we are calculating it and printing. Then we are saving the best one. So this condition allows us to find the best model among these candidates. So, okay. So as you can see, we have these values for the reach. So let's again take listen to our audio file. So this is the initial one. So after adding the noise, we obtain this one. And our result is for the reach, we obtain this. Also, I would like to show you the formula which we use to compute the signal to noise ratio. As you can see it here. So this is SNR equals 10 log out of 10 P signal or P noise. Indicators like that. This one. So thank you very much. Goodbye.